Okay, so what has happened is I just decided to have some more fun, and it's not necessarily part of the course, but managed to get some circular patterns. I still don't understand what's happening, but anyway. So what I've done is first of all taken the lattice size to be 100. So I'll just tell you the changes that I did while wanting to play around because yeah. So Lx equal to 100, Ly equal to 100. And the other thing that I have done is, of course, kept dt equal to the same values. Now, diffusion constant at the moment, I started out with diffusion constant of A being 1, diffusion constant of B being 100. You see that it's 30, but I'll slowly change it back to 100. Alpha is positive 0.005. Okay, and beta is 10 as previously. Total number of iterations have intentionally increased to 40,000. Sorry, have increased from 40,000 to 60,000. Number of snapshots, I'm keeping it the same. The major difference that I did was not start from what is it called, values of initial condition varying between +1 and -1, or minus zero point 0.5 and minus zero point 0.5 and plus zero point 0.5. Sometimes I was or even playing with 0 and 1, but I didn't understand what's happening. So what I decided to do is switch this random number generators for both. I just switched this off, uh, commented these all these things off. Okay. Yeah. So and so correspondingly, this also is off. All that I've done is initialize both the density of a variable and v variable to be zero throughout, except one drop, one lattice, a small perturbation in the middle of the lattice. And the rest of the code is just identical to what you had. The other thing that I did, of course, since this is 60,000, so both for domains A and B, uh, I changed this from 0 to 60. And while compiling, so 100 cross 100 lattice takes a bit more time. So what I'm doing is compiling with the minus O3 option. What this does is optimize the code, compiled code appropriately, so that there are fewer cache misses. And I don't know what else it does, but it we'll see that the code will run relatively faster. I'm compiling it. I am of course running it, but now it's running up to 60,000 iterations. And as you will see, what will happen is, uh, so I am just running domains B. It has run up till 60,000 iterations, as you see. And using Octave, I'm running domains B. First, it becomes white, nothing happens. But suddenly, after some point of time, uh, you see what is happening, right? The circular patterns start appearing, and they even appear here. Now, of course, one has to play a bit to, and I'll tell you how I'm trying to, I'll later try to figure out what's happening. That's why I'm recording this. And I also don't know for this value of parameters how A varies. Well, there are some strange things happening in the middle. It's trying to form patterns, but yeah, well, I'm seeing this myself. These. But remember, there was only one dot initially. Okay, I see. So this is what happens. You see these circular patterns, and here it would have formed a pattern, but these droplets have the droplets. So if I run it longer, I'm sure this is going to be also a circular pattern. Now, the thing for me to check is, can I control the, of course, the question is why, but first I just want to play around a bit and see if I can get larger number of circles. One, two, three, four. Right now it is till five. In fact, the reason I went from 60 lattice to 100 cross 100 lattice is so that you can get more rounds of uh, the circles, right? And of course, you can see the range here. Well, it's minus zero point 0.5 to plus zero point 0.5 as I see. Never mind. What at the moment I'm interested in is, okay, maybe for domains B, I will also increase the range. Oh, okay. Let's see what happens. Um, and for wonder what is it for domains dot m. Domains dot m, the range is minus 1 to plus 1. Okay. Anyways, I'll just keep that at the moment. And if I increase the diffusion constant, let's see what happens if I increase the diffusion constant to 100, back to 100, not to 1000, but to 100. And I, of course, compile and run, right, up to 60,000 iterations. And I gave it with the minus option, of course. No, so here you have basically one, two, three, four. And yeah, so I think the width of something has increased. Now, okay. What about domains B? Well, domains B is going to follow this, as we know. But here again, now previously it had become all white. Now you can see more prominent patterns appearing earlier for whatever reason. Of course, I changed the range as well. Now, where does this come from? Uh, I don't have much of a clue, but okay, I understand. The run had not completed actually. Okay. Now, what happens if I change the value of, let me decrease this a bit, see what happens. Basically, well, if I put that to 0, I think nothing much happens in terms of the width. Okay, becomes stationary pattern. But now if I increase this, if I increase the diffusion constant, what happens? Maybe I should first try to figure out what's happening and then do this parameter playing, because at the moment I'm doing it blindly, as you can see, because I don't understand why circular patterns. Of course, one could put two circular patterns as well, but we'll do it in some time. So let's see what happens. Ah, now you have fewer circles. And then you have these, I see, that's interesting. Things are still evolving. So now if I suppose decrease it, right? Hmm. And just stabilized for whatever reason. And now if I decrease this to 5, what happens? So can I? Hmm, whatever. You have these extra peaks. The point is, I don't understand what's happening, and to try to just before trying to understand, what I'll do is introduce two droplets. Uh, okay, and I'll increase the perturbation of this. Let me see what happens. Just before. Hmm. What happens? Okay, I see. Now, what happens if I decrease the diffusion constant of P, right? And put this also into, sorry, x by 4 and x by 4. Okay, there are these two source terms from which things are spreading out. Okay, I don't fully understand. Now, if you had to understand what is happening, we know that we have one small fluctuation. I mean, we're given a small perturbation right at the beginning, right? Uh, and if you want to understand better how these things are evolving, what I intend to do is look at the perturbations not over 60,000 iterations, but long number of, I mean, a pattern has fully formed, but just observe how things are fluctuating, say, every 20 iterations, so that I see how the perturbations are building up, right? And let me, uh, so if I'm running for So basically, let me run for, let me say, 2000 iterations only. So if it's 2000 iterations divided by 20, that's 100 snapshots, which will be created, right? So, yeah, 2000 divided by 20 is 100 snapshots. And then correspondingly in the domains, I have to make these changes. Uh, make these changes. This is for domains and this is for domains B. So that I can very minutely observe what changes are going on. Uh, yeah, I think that makes sense. Did I did it consistently? Yes, I. This has happened. Uh, Now let's see how do patterns emerge. Actually, 2000. Okay. Also, I want to slow down the domains. I want to watch each pattern not as a very swift, want to register what's happening. Nothing much is happening. Now, this was a slight dot and it is even vanishing. It's like uniform. No, no, something is appearing here. It hardly can be deciphered except that this thing is growing. Okay, so it was initially having this brown color, and the reason we can't see is whatever changes are happening are at an extremely small scale. So if I run this entire movie again, where we change the range of the x and y axis, say from, things will become a bit more visible. We'll see, we'll need to decrease it further. So I'm not running it again, but just plotting it with a different color of the c-axis. This was white, and now one can see these perturbations emerging. So this point has gone to 1 definitely. But rest of it, it is being beta, I think, is dominating in keeping it down. But all over this color has changed from brown to pink. The so here it is white, it has reached 0.1, but otherwise, oh, so every point it is being pushed. Okay. Now, if do this, maybe you can see something else. Now I'll also increase the speed a bit. Mm, I see. Putting it to zero was not a great idea, but I realize. Mhm. So data is the same, I'm just plotting it differently. So A is trying to basically increase where beta is putting it down, and hence there are these traveling waves or whatever you want to call them. Yeah, hello. Uh, I'm recording a bit. Itu par. I see. Whatever. So this become 0 point somewhere here. It has reached some value here. This point is uh okay. Whatever. Okay. Now if I increase from 0.005, suppose I increase this to 0.1, what happens? Will it become brighter earlier? It should, I thought. Yeah, more material is whatever, density of A is increasing faster. What is B doing? We'll observe B, the variation of B next. Ah, so it's becoming brighter blue. The value is increasing all over. This point is anyway right. So locally is constantly trying to increase. I think this center it has reached this fixed point, but B is pulling it down. I see. Ah, B is dead. B is trying hard to be zero, where A is trying to constantly fluctuate, and at some point later, B starts following A. I see. So it's a delayed. B has a delayed response. Now, if I increase beta, will it be further delayed, or I think it should E minus B, right? So if I increase beta to say 20, let's see what happens. A is increasing and B will increase the difference between A and B. So it should most probably follow it faster. Let me see what happens. Everything is static, everything is zero. Brown color corresponds to zero value. Hmm. much. Let's slow down even. No. Some changes are constantly happening. Well, I couldn't figure out much. Let's look at domains A. Okay. So it takes much more long. So this A and B are constantly competing. Okay. Okay. I think it will be more fun to decrease B. We don't see much happening except that this is becoming bright. Now, if I decrease B to 3, let's say, see what happens. Hmm. Changes, whatever changes, becoming faster. I see. It's trying to spread out from here. A is trying to constantly increase at each point, and it's but B has been pulling it down, and only when A reaches a certain larger value does B start following A. Oh, wow, this become white. Okay, let me see what B does. Nothing much seems to happen. We'll see when A reaches a certain threshold value, then B is forced to follow it. Okay, I'll increase the value of B, diffusion constant of B. I'm looking at B still. Actually, it's all zero, brown color. Hmm. And it starts following A. Just remind you, zero is brown color. Okay, so what does A do? He is constantly trying to increase. It is being pulled back, I think, by B. But it wins over. If alpha was equal to zero, then what would happen? I think it would be okay. So you have a circle here. But over a long time, actually, you have these circular patterns. They simply win over. And there are these, I see. Now, if alpha was set to zero, we still have these. I don't think so. Oops. Whoa. from a certain point, center point basically distributed itself to. Oh, something is happening very slowly. It's not decaying. There's no time dependent patterns, it seems. I mean, we always had time dependent patterns, but yeah, so some part is negative, large part is zero, and this is positive. So now there are things which are going out and then again came in. Hmm. Let's see. Now, if I increase diffusion constant of P, what would happen? And I want to also back to 1, and also domains P. I want it, oh, 0, 5, 0, 5. So much. Okay. Now, if we do domains P, mm, B starts following A. Anyway, when can I guess play around a bit? I'll stop recording and keep playing. Stop sharing and stop recording.